All right, I just got a message that we have to start over. Okay. Can everybody hear me okay? Okay. I think we're good now. Sorry about that. My name's Craig. I'm with Polycore Natural Stone. Today we're going to talk about Indiana limestone. A little background on me. I've been in the industry since 2009, both as a quarrier and a fabricator, working with dealers and stone fabricators, but also working with masons, general contractors on commercial and residential projects. So we're gonna run through the presentation. If you would, any questions you have, please enter them in the chat, and then we'll answer them after the presentation is over. With Polycore Natural Stone, we may be the largest stone quarrier that you've never heard of. Polycore has been around since 1987, but under the Polycore name are some very well-known stones like Indiana limestone, Cambrian black, American mist. We have well-known divisions, our Rock of Ages Memorial Division that does headstones and mausoleums and sculpture type, monumental type work. And then we have Swenson Granite retail stores in the Northeast. Our only non-stone offering is our Vitrazo countertop slab. So Vitrazo is a countertop slab that's made, 85% of it is made out of recycled glass. So an important thing to know about some of our quarries is that 12 of our quarries are ANSI NSI 373 certified sustainable. It's a rigid certification that we've achieved. And why this is important to you is that if you choose our stone from a certified quarry, certified sustainable quarry, and a certified sustainable fabricator fabricates that stone, it can help with your project earning lead credits. Whoops, I'm a little too far ahead there. Okay, our learning objectives for today. Today we're going to gain a better understanding of Indiana limestone quarrying and fabrication. We're going to learn some specifics of designing with Indiana limestone and learn about some alternate applications of Indiana limestone other than traditional masonry. This really is an Indiana limestone 101, kind of a primer, Indiana limestone, introduction to Indiana limestone, call it what you will. Today's course is certified by AIA, and you'll receive one learning unit. We'll make sure to submit that after the presentation is over. Submit your attendance. So we're going to jump right in. What is Indiana limestone? Indiana limestone is a sedimentary stone. It was composed of calcium carbonate that was formed over 330 million years ago by the cementing of minute shell and fossil fragments and sediments on a shallow ocean floor that is roughly 3 miles wide by 28 miles long in southern Indiana. In this area, there are 8 quarriers of Indiana limestone. What's unique about Indiana limestone is that it's considered a freestone. It has a very unique deposition. Being a freestone, it has no weak cleavage planes, which means it can be cut, sculpted in any direction within the block of stone that we pull out of the ground. So this allows Indiana limestone to be very intricately carved with ease, while also being a very long-lasting and durable building material. And lastly, Indiana limestone is classified by ASTM standards as a medium density type 2 limestone. And being a medium density type 2 limestone, it weighs in at about 144 pounds per cubic foot. So the history of Indiana limestone. The first organized Indiana limestone quarry opened in 1827. Indiana limestone saw increased demand in the late 1800s. Primarily started out as a localized building stone, but in the late 1800s, fires in Boston and Chicago really started to increase the demand for Indiana limestone. I'll speak specifically to Chicago. In Chicago, Chicago was built in the 1800s with Joliet stone, a local limestone that was quarried right there in the Chicago area. And through the fires of 1871, that stone was decimated. So it proved to not be a very durable building material. By that time, our industry was already about 50 years old, and we had started to prove our durability. So when it came time to rebuild Chicago, Indiana limestone was a preferred building material choice, which is one of the reasons why you see so much Indiana limestone in the city today. So why does our history matter? Well, here we are almost 200 years later. Indiana limestone is still available. And if it hadn't proven its durability and longevity over this 200 years, it wouldn't still be so widely used. It's also important to note that our stone is still readily available. We're still quarrying it. There's still several quarriers and numerous fabricators across the country that are fabricating Indiana limestone. So our stone is still available to match stone that was installed on a building over 100 years ago. So it's readily available for future additions and restoration, readily available for new commercial and residential projects. So now we'll move on to the quarrying of Indiana limestone. So when we get into the quarrying of Indiana limestone, here we see the first, or a typical Indiana limestone, the cross section of an Indiana limestone quarry. That upper layer, the St. Louis layer, we refer to as overburden. It has no dimensional capability, so we drill and blast it and haul it away to expose the Salem layer, which is true Indiana limestone. Now, that St. Louis layer doesn't go to waste. It's generally crushed into aggregate and used for construction fill and road DOT purposes. And then once we expose that Salem layer, we start to set up our quarry equipment to begin to then saw the stone out of the deposit. Now, each Salem layer is going to have a range of anywhere from 3 to 5 ledges or benches. You can see the sawn ledges or benches in this photo here. Each ledge is roughly 12 feet in height, and then directly below, not labeled on the slide here, but directly below the Salem layer is a layer of stone called the Harrodsburg layer. Just like the St. Louis layer, it has no dimensional capability. So once we hit the Harrodsburg layer, we cease quarrying in that area and move on to another area within the quarry. So now that the overburden has been removed, we bring in our quarry saws and set up our saws. We map out our quarry ledge to try to extract the highest quality, highest yield Indiana limestone that we can. Because that's what our fabricators want. That's what they want to provide on your designed projects. So you can see our quarry saw, our general quarry saw is basically a big chainsaw with a diamond belt on it. Typical quarry cuts are spaced at about 4 foot 6 inches apart. Will be roughly 12 feet in depth, and that depth is determined by the length of that quarry saw. And then those cuts will generally run about 54 feet in length. Now, most quarries are going to come in and they are going to cut up the entire ledge. And then once they have the entire ledge cut up, the saw crew will move to another area of the quarry. And here's where then the extraction crew will come in and begin extracting the Indiana limestone from the deposit. So the first step in doing that is to lay down a soft bedding material. We're going to tip over those cuts, those walls that the saw crew cut up on the ledge, and we're gonna tip those over so that we can break those into smaller, more manageable sized blocks. So we lay down a soft bedding material, which is just a pile of dirt and rocks and mud, and it softens the fall of that wall turning. And in order to turn that wall, we slide several airbags into that quarry cut and inflate those airbags. And we push that wall over. So here we can see a wall that's just been pushed over. You can see the inflated airbags there. And remember, Indiana limestone is a medium density type 2 limestone weighing 144 pounds per cubic foot. So based on that, this 54 foot long wall, 4.5 inches thick and 12 inches tall, is going to weigh about 500,000 pounds. So quite a not a whole lot that we can do with a 500,000 pound piece of Indiana limestone. So the next step in the process is to break that wall up into smaller, more manageable sized pieces. So our quarry crew will come in, and just like they did the quarry ledge, they're going to map out that turned wall, and we're looking for any defects within the stone that we want to work around. Again, to provide the highest quality Indiana limestone to our stone fabricators and to our projects. So in this step, they'll map it out, and what you see here are the two pieces of equipment. The orange piece of equipment is a drilling rig. So we will mark where we want to break that block, and we will drill 36-inch deep holes, spaced about 12 to 16 inches apart, where we want to break that block. And then that yellow piece of equipment we are hydraulic splitting pins. So those pins get inserted into those drill holes. They increase in size and hydraulically, and they put just enough pressure on the stone to break it exactly where we want it to break. And here you can see one of those smaller, more manageable size blocks being hauled out to the grading yard to meet the next step of the process. At this point, that process is we look at those stone blocks and we identify the color of the stone, the grade, looking at the grain of the stone, and then we identify the usable measurements of each block. And all of this gets cataloged into our computer system and followed with a barcode so that we can process that through our system in preparation for sale. So now, all of that being said, what I just showed you, we generally refer to as open pit mining. And a couple of quarriers in our industry are now starting to delve into underground quarrying. And unique about this is, one, underground quarrying can occur year round. With open pit quarrying or open mining quarrying, there's water that's used in the process. There's water that's saturated in the stone, and quarriers have to be really careful about quarrying in extremely cold temperatures, thus freezing equipment, freezing blocks, which would then render them useless. So underground quarrying eliminates that worry. Another benefit of it is so we can quarry year round as an underground quarrier, but also we eliminate the step of needing to strip away all of that overburden. So that's a timely and an expensive process. So we can eliminate that part of the quarry process. So it's less disruptive. Now one of the caveats to the underground quarry method is it can be a slightly slower process. With both process, the underground quarry process tends to, we believe, tends to extend the amount of Indiana limestone that's available out of that 3 mile long by 28 or 3 mile wide by 28 mile long deposit to about 1,000 years of availability. With present open mining extraction, we're probably looking at about 500 to 600 years of Indiana limestone available for extraction and sale. So none of us have to worry about running out of Indiana limestone anytime soon. So now we're going to look at fabricating Indiana limestone, and I have a video that'll walk you through here. Interesting note: this picture here is what's named the Empire Quarry. So this particular quarry area of the Empire Quarry is where all of the stone came from for the Empire State Building. It is the only project that was quarried out of that particular quarry hole. And if any of you ever decided to visit our quarry, we could take you back to this quarry hole and show you exactly where the stone for the Empire State Building came from. Okay, so here we go with our beginning of our fabrication video. So every block, the fabrication starts with every block being sawn, and the thickness of those slabs will be determined by what you draw on your drawings. This type of a saw takes roughly 6 to 7 minutes to go through each cut on the block of stone. In we use a lot of machinery to move stone around. Our industry, we like repetition, so we use a lot of equipment that allows for repetition. And repetition is beneficial because it can allow us to cut multiple pieces of stone, be very efficient in fabrication, and thus get the durability and the value of a natural stone on your project at a budget conscious price. So here we just saw a saw that was cutting up 30 pieces of stone at one time. Here we see another saw with running 5 blades, currently cutting 3 pieces of stone out of a single slab at one time. the video here will get a little bit more exciting here in a minute. Another saw cutting about 60 pieces of stone at one time. Here we see a breaker that is taking stone and putting pressure on it just enough to put a split finish on it. And here we see a pitching machine that's putting a chiseled edge onto long, flat pieces of Indiana limestone windowsills. Here's where it gets exciting. This is a traditional stone planer, been in use since the start of our industry. It uses carbide bits shaped to the shape of the profile that you designed to shave the stone off of the into the desired profile. We use a lot of hand cleaning up and hand carving and chiseling to finish intricate details on pieces. This guy right here is quite an artist, using a visual template to turn balusters. It takes him about 30 minutes from start to finish, from a blank of stone to a finished baluster, to turn those on a stone lathe. A lot of again, a lot of hand equipment, a lot of grinders, a lot of dust used with Indiana limestone. And then, of course, also we can cut as much as we like repetition. Our fabricators can also cut single pieces of stone as a project needs. CNC machines have been much more widely adopted by our stone fabricators in our industry. This is a 5-axis CNC machine that utilizes blades and router bits. Simply programmed, all the work is done in the programming. Slab is set on the saw table, the saw is turned on, and a fabricator can walk away at night and come back to a nearly finished piece of a carved piece of Indiana limestone. Now, all that said, we still have a great group of hand carvers within the Indiana limestone industry. So while a CNC machine may be more advanced and more efficient, it can never quite express the authenticity that a hand carved piece of Indiana limestone or a hand carved piece that done by a talented stone carver. These gentlemen really and ladies really know their art well. This gentleman right here is a guy by the name of Walter Arnold. He's out of the Chicago area. If you Google him and look him up, check out his work. He really does some incredible work. And not knowing where all of you are located, if you have a stone fabricator nearby, I highly encourage that you take the time to visit with a stone fabricator. You're more than welcome to schedule a visit with our quarry. We'll take you through our quarry, through our mill, and we'll take you to some of our local fabricators so you can see firsthand the art and the beauty of fabricating Indiana limestone. So now we're going to look at some ideas around cost-effective fabrication, some things that I want you to know about the fabrication process as you're designing with Indiana limestone. First of all, let's talk panel size. So remember the staged quarry blocks that came right out of the quarry, right? These blocks typically yield a usable slab that will measure 4 foot by 8 foot. So if you design with that 4 foot by 8 foot size in mind, that allows for greater fabrication efficiency and thus greater cost competitiveness. An example, if you design a 3 foot by 5 foot panel, and our fabricators have to cut it out of a 4 foot by 8 foot slab, there's a lower material yield. And the fabricator then is going to calculate that waste, and it's going to be included in your project budget, which is going to drive the price up. So the more you can design around these ideas that help the fabricator be efficient, the more cost effective our stone will be for your projects. So we also like to work in standard dimensions. And being on the cut stone side of things, designing in standard dimensions, helps to increase that efficiency, but two, it also helps to cut down on the back and forth in the shop drawing stage, which tends to be a very time sensitive process. So some of the standard dimensions that our industry likes, that our fabricators like, are 2¼ inches, 3 inches, 4 inches, 8 inches, 10 inches, 12 inches, and anything to 5/8 of an inch. Most Indiana limestone is cut to allow for a 3/8 inch mortar joint. So a lot of dimensions then would be 3 5/8, 4 5/8, 5 5/8, and so on. So when you do this, and when you keep your piece dimensions in mind, if you can design your piece height and your depth to the 5/8 of an inch, that's just going to allow the fabricator more flexibility in nesting pieces within a certain slab thickness to allow for efficiency and greater cost competitiveness to your project budget. Now, as far as panel depth, most fabricators will not want to fabricate a panel less than 2 inches. And Indiana limestone cannot be adequately mechanically fastened when panels are less than 2 inches. There's just simply not enough depth or meat to that panel of stone to adequately hold the fastener in place without worry of the stone cracking or spalling at the point where that anchor is inserted into the stone. So I want to touch on finishes a little bit. This is just an example of some different finishes that are available from our fabricators, from bush hammer to sandblast to wire brush. There's different line cut finishes, hand pitched, meaning chiseled by hand. That bottom right is one that is chiseled by hand. There's a lot of different finishes that can be obtained. The point that I want to make is that finishes add either machine time or they're hand applied. So they add time, they add labor, and therefore will add cost. So I highly encourage you that as you begin this design stage, as you have your dreams in mind, your goals in mind of what you want to accomplish, to bring in a stone fabricator, somebody that, bring a stone fabricator in. We'll help pair you up with the right company to help accomplish your dreams. And we can walk you through all of the intricacies of fabricating the stone to meet your needs and help you understand what those cost implications may be to do a certain size or to do a custom finish or, to do, just really help you understand your budget before we get to the bid stage and realize that the stone cost is way over budget. So we like to try to figure all that stuff out on the front end. And then lastly, despite what I said about our general block size will yield a slab that is 4 foot by 8 foot, we can offer custom quarried sizes larger than 8 foot by 4 foot. It really becomes a discussion on the front end of what the need is, what the volume is, and careful coordination with the quarry to make sure that we work that into our quarry plan in time for your project to need it. Generally speaking, the cutoff is going to be around probably about a 5 to 6 foot by 12 to 14 foot long block at about 4'6" in thickness. So then it becomes an issue of can a block that size be handled by both the quarry and the fabricator? But we always welcome those conversations. So please bring those dreams of yours to us, and we'll walk through them with you. Next up, we're going to talk about just some basics in specifying Indiana limestone. In our quarries, we get 4 colors: buff, silver buff, gray, and full color blend. Now think back to that quarry cross section, and that top ledge within the Salem layer typically is going to start out as buff, and then as we move lower through the deposit, is going to turn gray. Now it's thought that the color difference is explained as being caused by the oxidizing action of groundwater that has moved through the stone deposit over millions of years. So it's believed that at one point all Indiana limestone was gray, and as that groundwater moved through the deposit, it changed where it moved through to that buff color. Now where the buff and gray meet, that's what we call full color blend. It's characterized as being an unspecified percentage mix of buff and gray. That's very important. An unspecified percentage mix of buff and gray. You don't get to choose, hey, I want it to be 50-50, or it can be a range. It could be 50-50, it could be 70-30, it could be 90-10. So understand that when we pull out blocks of full color blend, that color mix will vary. It's unspecified. And when a fabricator cuts stone out of that block, you will get some pieces that are all gray, some pieces that are all buff, and some pieces that will have that transition of buff and gray within the piece. Now, full color blend really truly represents the beautiful range of colors that's quarried in an Indiana limestone quarry. So what's silver buff? Well, in some areas of a quarry, we get into a deposit that yields a color that we call silver buff. Silver buff is similar in color to buff. It's also somewhat similar in color to gray, but it's not quite either. It's kind of somewhere in between. And quite frankly, as silver buff is quarried and as it ages, it tends to take on more of a buff color. So silver buff really is used as a price competitive alternative to buff. And we'll get into pricing here in just a little bit. Actually, we'll do that right now. So when we look at the raw material cost, buff is our highest demand, highest priced raw material. Full color blend is our lowest priced raw material. So very generally speaking, buff is being highest priced. Silver buff and gray are going to be close to about half the cost, raw material cost of buff. And then full color blend will be about a third of the cost of gray. Now, it's important to know this is raw material cost only, and cost to your project. A lot of the cost, the majority of the stone cost that's to your project is going to come from the fabrication and the install of the stone on the project. So we also have two grades from which we quarry. Grades referring to the grain of the stone. Standard grade is our most common grade. That's what we are seeking when we quarry. And it's going to show a range of fine to medium particles and a tight, consistent grain. We also have a grade called rustic. Rustic will exhibit a range of that fine, those fine to medium grain size particles that standard has, but it also will contain some coarser particles, maybe some pits, some shell fragments, some shelliness, and some openness to the grain of stone. So really, rustic tends to be a bit of a byproduct of quarrying for standard grade stone. So that's important to know. We always have rustic grade stone, but being a byproduct of quarrying for standard grade stone, the amount of available rustic grade stone can vary. So that's again where it's very important to discuss with your quarry, with your fabricator on the front end of doing your project, walking through what your dream is, what you want to do, and we can assist you with the right color and the right grade to use on your project. Now, cost-wise, just as I said with color, rustic is about half the cost of standard. So I want to look at a project to give you an example of why raw material selection matters to a project budget. This is 15 Central Park West in New York City. It was designed by Robert A.M. Stern in 2008, and it has 35 stories that are entirely clad in Indiana limestone. So the story is that Robert A.M. Stern came to us, gave us an understanding of what they were looking to accomplish in this project and their timeline. And originally looking at some different materials, brick being one of them, but then leaning towards Indiana limestone, and looking at our standard grade buff stone. But in the volume that was needed, 62,000 cubic feet total. So just for a point of reference, you get about 280 to 300 cubic feet of finished cut stone on a semi-truckload going to a job site. So this project required 62,000 cubic feet of Indiana limestone. So a large volume, but also the timing of the project wouldn't allow us to provide the standard buff stone that they wanted to use on the project. Now let's look at raw material cost. At 62,000 cubic feet, just the blocks required for this project before they left our quarry, before they made it to a fabricator, before they were cut into anything, amounted to about $3.4 million in raw material. So as we were talking through the project with Robert A.M. Stern, where we landed was, hey, we know you want this standard buff, and what's really important is that show on the bottom floor, maybe the bottom two floors, where it's highly visible to people at sidewalk level. And we have all of this other material, this full color blend that's readily available, ready to go for the project, and it's a lower cost. So when we did the math of doing the first two floors, remember 62,000 cubic feet, $3.4 million using standard buff blocks. When we did the first two floors in standard buff and the remaining 33 floors in full color blend, there was a difference in raw material cost of $2.72 million. So a great example of why you should discuss with your quarry, especially on a large scale project, what material to use and how it impacts your project budget. Now, all of that being said about color and grade, regardless of color and grade, all Indiana limestone will meet the requirements of ASTM C568, and we have the test data to prove it. So there's three tests within ASTM C578. The first being compressive strength, and that is how much can the stone crush before it breaks. The second test is modulus of rupture, and that's how much pressure can the stone take on a single point before it breaks. And then our absorption and bulk specific gravity, which basically we take a piece of stone and we weigh it dry, and then we soak it, let it absorb water over a period of time. We weigh it again, and that determines the absorption rate of the stone. So I know absorption in our Indiana limestone tests at about 4 to 5%, so well below the maximum allowed of 7.5%. Modulus of rupture is upwards around 900 to 1,000 psi, so well above the minimum ASTM standard. And then ultimate compressive strength is in the 5,000 psi plus. So again, well above the minimum required by ASTM standards. Indiana limestone is capable of being self-supporting, and we have an Indiana Limestone Institute that backs up our industry, and we have an Indiana Limestone Institute handbook. And in that handbook, on page 37, is what's known as a beam and lintel table, and it's a simple mathematical calculation that tells you, based on the span that you're looking to cover, how tall and how deep your piece of Indiana limestone needs to be in order to be self-supporting. So we're happy to walk you through that calculation, or put you in touch with the director of the Indiana Limestone Institute to walk you through some of the technicalities of that. When you're specifying Indiana limestone used at grade, on grade, or at grade, at or below grade, it's very, very important to specify the use of a damp proofing material. Indiana limestone is an absorptive stone. It's going to take on moisture. It's going to exhaust moisture from its surroundings. Sometimes you'll hear this called rising damp. Now, if rising damp comes from a concrete slab, a concrete foundation, concrete block, or a mortar setting bed, the moisture in that concrete will be alkali charged. And the stone is going to absorb that alkali charged moisture. The natural path is for the stone for the moisture to exhaust through the face of the stone. And when it does that, it will leave those alkalis deposited on the face of the stone in the form of a kind of a brown, hazy stain. Damp proofing is a cementitious barrier coat that's put on the back and sometimes the sides and the bottom of the stone to prevent it from absorbing alkali charged moisture. Here is one of the most extreme examples that I've ever seen of pool coping, with alkali. We refer to this as alkali staining. The damp proofing step was skipped, and you can see on the left of the slide how severe that alkali staining can be. Now, the good news is that will eventually dissipate, but it's dependent on the natural wetting and drying, the weathering that the stone will go through as those alkalis are weathered away off of the face of the stone. So it's a really very important step to include in your specification, and do your absolute best to make sure that this part of the process does not get VE'd out by the mason, the installer, or the general contractor. While we don't recommend any particular supplemental products, we do have any one specific supplemental product. We do have some products that we can steer you towards, and then you can verify with the manufacturer of those products if they're a good fit to use on your project with Indiana limestone. We get a lot of questions about anchor selection. We are not engineers, so we tend to shy away from offering too much direction regarding anchors. To the left of the slide, there are multiple factors that must be known and understood when considering the right anchor for your project. So very general advice: design with stainless steel anchors, or at a very minimum, hot dip galvanized anchors. I like stainless steel. Hot dip galvanized, eventually moisture will get in your wall. Moisture will contact that hot dip galvanized anchor, and that zinc coating will do its job. It will begin to sacrifice itself. And over a long period of time, eventually you can expect that zinc coating will wear away and expose the bare steel of the anchor underneath, which then will cause rusting and eventual failure. So highly recommend stainless steel anchors. I advise that you make connections between your anchors and the stone with the fewest components as possible, and limit the number of different types of anchors that are used within the same project. Keep your installer in mind and try to help make their job as simple and easy as possible. Always design with adjustable anchors. This is going to allow for the inevitable construction tolerance that the mason or the installer is going to have to encounter when installing Indiana limestone. And then distribute the weight of the stone. Make sure that as the anchors, the anchor placement is designed to make sure that allows the weight of the stone to be evenly distributed across all anchors, all anchor attachments within the project, and to eliminate trapping any moisture in those anchor slots and anchor points. Another big question that we get asked is, what should I use to seal Indiana limestone? And there are sealers out there that you can use, but I don't recommend using or recommend sealing Indiana limestone in exterior applications. Our stone is an absorptive stone. It should be allowed to breathe. And even breathable sealers may not allow the moisture to exhaust rapidly enough, especially in areas where rapid freeze thaw can occur. Long-term trapping of moisture in the stone can result in cracking and spalling on the face of the stone and eventual failure. So additionally, when you seal Indiana limestone, or any stone for that matter, you may change the appearance of the stone. With a sealer being a coating, no sealer can get applied evenly on every piece of stone. And at that, the stone may age at different rates, causing a very uneven and mottled look as the stone ages, caused to inconsistent sealer thickness during application. And then lastly, think about the maintenance cost of sealing. Once it's sealed, that sealer is only going to last for a period of time, anywhere from, call it, 3 to 7 years. And that sealer is then at that point probably going to want or need to be reapplied. Does your project owner know what that long-term maintenance cost is for continual resealing of the stone over the life of the building? The one area where I don't mind recommending sealing Indiana limestone would be interior applications, where the stone is not subject to any freeze-thaw activity. So my recommendation there is the stone is quarried, the stone is fabricated, the stone is installed. Let the stone sit in its environment for a period of time, ensuring that it's dried out before any sealer is applied to the stone. Next up, we're going to talk about cleaning Indiana limestone. So in general, the same cleaning recommendations apply, whether you're cleaning newly installed Indiana limestone or performing a general cleaning to remove dirt and organic matter. Now, I always recommend starting with the least aggressive cleaning methods and adjusting cleaning based on the staining and cleaning required. So first recommendation, start with low pressure, clean water, and a soft bristle brush. Light detergents can be used. Something as simple as trisodium phosphate, which can be bought at any big box store, or even something like a Dawn dishwashing detergent can do wonders to remove stains from Indiana limestone. Next, high pressure wash may be used, and it can be very helpful in removing stains and organic matter, as you see in the picture here. But as with any material, high pressure wash done inadequately could etch the surface of the limestone, and it could leave uneven swirl marks that would be challenging to remove. So the recommendation is no more than 1200 psi pressure wash with a wide fan tip, no closer than 12 to 16 inches to the face of the stone. Now, in new construction, mortar smears can be cleaned first by knocking down the smear with a trowel, wetting the stone with water, and scrubbing with a soft bristle brush. You can use white vinegar to assist in melting that mortar smear off of the face of the stone. There are cleaners that are made that contain acid. Vinegar is an acid that can also help with more easily removing that mortar smear from the face of the stone. But Indiana limestone being a calcium carbonate, anything with acid will cause the stone to react and will react negatively. So it's very important to follow either the cleaning products guidelines or follow this general information if using or specifying to use white vinegar to clean the mortar smears, and that is to thoroughly wet the stone prior to cleaning. And by doing so, you allow that white vinegar or that acid-based cleaner to sit on the face of the stone rather than be absorbed into the stone. Once it's absorbed into the stone, it can cause acid burns and degradation to the stone. And then once the mortar smear is clean, then a very thorough rinsing of the face of the stone to remove all traces of the white vinegar or the acid-based cleaner. So now very stubborn stains like a oil stain, a wine stain, anything that can penetrate deeply into the Indiana limestone can be removed with the use of a poultice. These can be purchased commercially, but they can also be made very simply by forming a paste by mixing stone dust or gypsum with water. You create this sludge of sorts. You place it over the stain. You cover that with plastic and you let it slowly dry out. And what happens is the moisture in that poultice absorbs into the stone, and as it dries out, it pulls the stain out of the stone, and it's surprisingly effective. And then lastly, some restoration contractors may use a misting station. And this is an excellent way to remove decades of grime and organic deposits on Indiana limestone. And how this is done is this is set up on the building, typically at the very top of a building on the copings, and where you get a lot of that carbon buildup. And the misting station will wet that buildup and keep it perpetually moist. And in doing so, eventually it softens enough to be removed with more conventional methods like soft bristle brushes and high pressure wash. So one of the great things about Indiana limestone is the design flexibility that it gives you. You can do very simple flat panels. You can do all the way to very intricate carvings. And our industry has some very cost-effective standard products that are offered to the design community to get Indiana limestone the value and the durability of Indiana limestone on your project at a budget-friendly price. So a few products that we'll look at here. Here we see a random size tumbled Indiana limestone, typically going to range from about 2 to 12 inches in height, random lengths from around 12 to 24 inches, all random, split face and tumbled, provides a very rustic look, and it's available in full bed and thin stone. Here we see a typical ashlar pattern. It's a dimensional split face. Standard heights are 2 1/4, 5, 7 3/4, and 10 1/2. Lengths to the job site generally are going to be about 3 to 4 foot in length, and then the installing mason can break those into shorter lengths to create the pattern desired that you show on your drawings. And this also is available in full bed or thin veneer. We also offer smooth modular units. Remember me speaking of repetition and how much we like repetition. This is a great product that's produced in repetition and offers a very competitive price, budget price for your project. Typical heights are going to be 4 inches, 8 inches, 12 inches, and 16 inches. Typical lengths will be 24 and 36 inches. And all sizes all are sized to accommodate a 3/8 joint. So it's going to be 3 5/8, 7 5/8, 11 5/8 heights, for example. And this, again, also is available in full bed and thin veneer. And then lastly, Indiana limestone pavers are a great product to use, whether in a light commercial or residential application. Generally coming in thicknesses of 1.5 inches and 2 inches, and standard sizes of 12 by 12 up to 24 by 48, and also like the veneer, like the smooth modular unit, are dimensioned to accommodate a 3/8 inch joint. This photo here is a great example of full color blend, and you can, as you look closely at it, you can kind of see the range of buff and gray color. So never hesitate to reach out to us and talk about how you can incorporate a standard product from our industry into your design and what the cost impact of doing so is for your project. So a couple of different ways of utilizing Indiana limestone other than traditional handset masonry. The first we're going to look at is stone face precast. So in this type of an installation method, the stone is fabricated just as it would be if it were to be handset by a mason on site. But rather than going on site and installed by the mason, it goes to a precaster. So this fabricated stone is laid face down in a mold. Anchor points are identified. The concrete is poured onto the back of the pieces of stone. And then once that concrete is cured, it is then pulled out of the stone. So you essentially have a very large panel with multiple pieces of Indiana limestone adhered to it, and then shipped to the job site and lifted in place. Most recent, one of the more familiar projects that was built using Indiana limestone on precast was Yankee Stadium. It was built in 2009, designed by Populous, and utilized 11,000 pieces of Indiana limestone. Another method other than traditional masonry would be veneer rain screen. So aside from its rain screen benefits, stone as a veneer rain screen allows for a very rapid installation, and any number of trades can quickly be trained on proper installation. In the system, an aluminum track is anchored to the building, and then the stone panels are attached to the track with clips. And this is a great example where repetitive piece sizes are very helpful to simplify install and keep costs competitive. An example of a project installed in this manner was the Patrick G. and Shirley Ryan Center for the Musical Arts at Northwestern University. This was designed by Getch Partners, completed in 2015, and used standard buff Indiana limestone. And then here's an example of, well, I don't have a clearer picture of the product itself. This is Luddy Hall at Indiana University. Also a rain screen system, but this, instead of using a thin, a panel of a 2-inch thick panel of stone, it uses a laminated stone panel. So in this type of a product, a very thin piece of stone, about 3/8 of an inch, is laminated to aluminum honeycomb, and then hung on to the track system, the aluminum track system with clips. It's extremely lightweight. It's very rapid, can be installed very rapidly, reducing install cost, reducing the structural requirements of a building because it doesn't have to manage the heavy weight of a full thickness panel of Indiana limestone. Luddy Hall was completed in 2018, and Pelly Clark Pelly was the design architect with Ratio, excuse me, out of Indianapolis acting as the executive architect. So a few humble brags of our stone. Here we see the Biltmore Estate in Asheville, North Carolina. It was designed and complete by Richard Morris Hunt and completed in 1895. From February 1891 to February 1892, our industry shipped approximately 287 train cars of 60,000 cubic feet of Indiana limestone blocks to the project site. And all Indiana limestone was fabricated on site at a stonemason shop built specifically for the Biltmore. Here we see the Empire State Building in New York, designed by Shreve, Lamb, and Harmon and completed in 1931. It reaches 102 stories and 1,454 feet in height and used 200,000 cubic feet of full color blend Indiana limestone. Here we see the National Cathedral in Washington, D.C. It was designed by George Frederick Bodley, Henry Vaughn, Foreman Robb and Little, Frederick Law Olmsted Jr., and Nellie B. Allen. It was constructed between 1897 and 1990, so almost 100 years. So that really speaks to the color range consistency of Indiana limestone and that it could be provided on the same project over almost 100 years and still look very consistent. And the National Cathedral is really a great testament to the versatility that you have to design with Indiana limestone in that it uses very simple flat panels, but also very intricately carved pieces throughout the cathedral. Here we see the University of Denver Nelson Hall that was designed by Bennett, Wagner, and Grody Architects. It was completed in 2002 and uses full color blend. If you look closely at some of those surround pieces or those profiled pieces at the opening, you can see some of those transition pieces from the buff to the gray within the piece. The University of Denver almost exclusively uses full color blend when they design with Indiana limestone. And one of the things I want to point out here is the base of the building, different color of stone. It's important to note that when you're designing with Indiana limestone that salt and ice melt materials will attack anything really that they come in contact, but especially so Indiana limestone. So it's very common for architects to specify a harder stone like a dolomitic stone or a granite at the base of a building to help to resist the degrading effects of that the ice melt or salt used in cold weather environments. Here we see Simon Hall at Indiana University, designed by Flad and Associates and completed in 2007. It was awarded Project of the Year in 2008 by Masonry Construction Magazine and is built entirely out of standard buff Indiana limestone. Here we're at Washington University's Brower Hall in St. Louis, Missouri, designed by RMJM Architects and completed in 2010. This uses standard buff complementing a red Missouri granite. It's an absolutely beautiful campus to go see all the intricate stonework on all the different buildings throughout the campus. And here we see the Walter Washington Convention Center, designed by Thompson, Vanderlet Associates, Devereaux and Purnell Architects and Planners, and Mariani and Associates. It was completed in 2003 and uses standard silver buff Indiana limestone. Here we see Royal Alberta Museum in Edmonton, Alberta, designed by Dialogue and completed in 2017 using gray, standard gray Indiana limestone. Our industry does an awful lot with high-end private residences. Here we see one in Toronto, Ontario, completed in 2005 using standard buff. And we also see a lot of art installations and carvings done with our stone. This is called Awakening Muse. It was designed and carved by Don Lawler and Meg White, and it's installed at the Prairie Center for the Arts in Schaumburg, Illinois. Here we see a carving called Birth of Flight at the Indianapolis airport, carved by Todd Fromm. And the carving depicts the American Sign Language sign for butterfly, and it was installed in 2010. And then lastly, we see the Northern Trust Building in Milwaukee, Wisconsin. This one was completed in 1906, designed by George Bowman Ferry and Alfred Kloss in the Beaux Art style that was very popular in the U.S. between 1885 and 1920. So well over 100 years old and still holding very sharp and intricate details of the Indiana limestone on the building. Here we see a study that was performed by Dr. Greg Jones and Professor Jeffrey Hammond and published by Circular Ecology in 2019. It compares the embodied carbon of many different building materials. And embodied carbon is the sum of fuel-related carbon emissions and process-related carbon emissions to produce the material. Natural stone, as you can see at the very top, has the lowest measure of embodied carbon of the listed building materials. Indiana limestone contains no VOCs. It's 100% recyclable, and it offers extreme 100 plus years of durability, all factors that contribute to it being a good, sustainable building material. We have the supporting documentation to help you earn LEED credits. We have the HPDs and the EPDs and the necessary documentation about certified sustainable quarrying. So whether it's LEED accreditation, the Living Building Challenge, or some other sustainability standard that you're seeking, Indiana limestone can help you get there. Aesthetically, so why should you use Indiana limestone? Well, aesthetically, I think it's a beautiful stone. It performs. It looks great as a standalone material, as the sole building material on a project. But it being neutral in color, it's also a great complement to many other building materials and colors. Indiana limestone has proven durability. We don't have a warranty, but our warranty is the longevity of the stone being used on projects like the Biltmore Estate that was completed in 1895, like the Tribune Tower in Chicago that was completed in 1925, like the Empire State Building that was completed in 1931, along with hundreds of other projects across North America that all demonstrate the durability that you'll receive when you design with Indiana limestone. So remember, Indiana limestone is considered a free stone. It can be cut, carved, and shaped in any direction, lending it to be a very versatile stone to design with, from very simple flat panels to intricate detailed carvings. And then lastly, Indiana limestone is a sustainable material. It was created by nature. It was formed over millions of years. There's no carbon-intensive manufacturing processes required to create the stone. It overall has a very low carbon footprint. And the steps to get Indiana limestone to your project are very minimal, from quarry to fabricator to job site. So that concludes the presentation. I hope you'll consider joining us on June 24th for our natural stone facades and cladding presentation. At this point, I will stop with my presentation, and I will be open to answer any questions that have come through during the presentation. Okay, thanks everybody for hanging in here with us. Let's see here. Are joint sealants ever used with limestone in lieu of mortar? Maybe at limestone to brick? Yes. Joint sealants are used. It's very, very important to run some testing on those joint sealants with Indiana limestone. Remember me saying that Indiana limestone is an absorptive stone. There could be chemicals within that sealant that when it touches the limestone could absorb those chemicals, which could then cause staining or in some cases shadowing of the stone. So we can point you in the direction of some materials, some sealants that we know have worked with Indiana limestone. But again, it's always, manufacturers are known to change their formulations. So it's always important when specifying a particular sealant with Indiana limestone to note that that should be tested with the stone to make sure that no staining will occur from that sealant. So thank you, James, for that question. What damp proofing product do you recommend? We have a couple. The one that I refer to mostly is known as Master Seal. It's gone through several different company purchases. Started out as Master Seal, Thorough Seal. Then it was owned by BASF, and I believe now it's owned by Sika. Master Seal, I believe the number is Master Seal 583. If you Google that, you'll find a good damp proofing product. But again, I encourage you to consult with the manufacturer of that product to make sure that it's a good product to use with Indiana limestone. Our experience says that it is. I'll hang out here for a little bit more just to see if any more questions come through. If not, that's the end of the presentation. So you're free to drop off. Sorry for the technical difficulty there earlier, but I'm appreciative that you all hung in there and stayed with us. Thanks, everyone. James, thanks for the question on the certificate process. I'm not exactly certain what the certificate process will be, but I believe when you signed up for the presentation, you submitted your email address. So we will take your AIA numbers and submit those to AIA, and then I would expect that then we would email you a certificate so that you have a copy to have. Oh, there we go. Thanks, Stephen. Stephen says we have your AIA number and information, and we get those submitted as well as the certificate. Okay, I don't see any more questions coming through. So thanks, everyone. I hope you all have a wonderful rest of your day, and we appreciate you joining us. Have a great day, everyone.